This video is going to be all about capacitors and what they are and how they function and what they're actually used for. Now, capacitors come in many different shapes, sizes and capacities, if you like. Let me show you a couple of examples of what they actually look like and some examples of how they come and what form factor. Now, this is commonly known as an electrolyte or an electrolytic capacitor. It's basically made of like an aluminium foil and a dielectric, which means that electricity cannot pass through, and these are polarized, as you can see. That is the negative indicated by that white band or that band there, and a positive which has no indication whatsoever, and they have to be put in the correct polarization in a circuit, otherwise you're going to have problems. And I may even blow one up just to show you reverse polarity on. So as you can see, this electrolytic capacitor shows a value of 50 volts 1000 UF, which is microfarad. A small u generally means micro in electronics or computing. That's just a model number of the type of capacitor. They have different ratings, temperature ratings and all that sort of stuff. You can look up a data sheet for, if you so wish. I may even include one for this one specifically. But as you can see at the top, you can see like a grooves cut into the top there. Now the problem with these capacitors, or some capacitors, is the electrolyte inside, which is actually a liquid, can actually get just a bit too hot, and what can actually happen is it creates a gas on the inside, which then can cause a capacitor to actually explode. Back in the day, they used to have just a flat piece of metal on the top, if not just a flat piece of plastic. Nowadays they have these what they call vents, so if this decided to build up with gas, that will actually break open the top and hopefully expel the gases safely. They still do sort of go up with a bang though, so they still can be potentially dangerous. So that's an electrolytic capacitor. What else is there to say? Let's say, yeah, they're polarized, and a shorter lead indicates negative, a longer lead indicates positive. And I say I may actually reverse polarity on one of these just to show you guys what actually happens or what potentially can happen. So this one again is rated for 50 volts and it's 1000 microfarads, and microfarads is the measurement of energy, and 50 volts is the measurement of voltage that this particular capacitor can handle up to. For example, if you have a 20 volt circuit and this capacitor was sitting on the output of that 20 volt circuit or power supply, this would be ideal because it's rated at 50 volts, so you've got that little bit of safety margin above that. If you had 20 volts on the output, for example, and you had a 20 volt capacitor, it would potentially work, but you would potentially limit the life of the capacitor doing its job, and obviously would cause it to overheat and actually build up that gas and vent early. So it's a good idea to generally double your voltage. So 20 volts output on a power supply, for example, 50 volts would be more than adequate. 12 volts output on a power supply, then 25 volts would be more than adequate, so on and so forth. So let's have a look at some other different types of capacitor that you'll generally find in a power supply circuit, for example, because they generally have quite a few capacitors and different types of capacitors which actually serve different types of jobs within the circuit. This is another type of capacitor that you'll probably most likely be familiar with, or if not, that's why I'm doing this video. As you can see, this is also a capacitor, and you can tell it looks a hell of a lot different form factor, and also different purposes, which I'll go into maybe in another video or maybe in this one, depending if I can fit it in. Now if we have a look, if I zoom in onto this one, there's actually markings on here. You can see that it looks like it's rubbed off actually. Good example, isn't it? Anyway, yeah, you do find that they will have markings on them. See if I can get the right light on that. Yeah, I can't read it on the viewer screen, but There are markings on there that should tell you, again, the capacity or the capacitance of that capacitor. This one is typically called a ceramic disc, obviously because of the disc, and presumably I would imagine there's probably ceramic, some sort of form of ceramic in there. Now these, unlike the electrolytic capacitors, do not store electrolyte, hence why they're not called electrolytic capacitors. So these do not tend to vent, and they don't build up with any kind of gas that's on the inside. So these don't kind of act in the same sort of way. They have a similar sort of function, again, which I'll go through maybe in a bit. They're not polarized. You can put them in any orientation in the circuit. You can put them plus minus, doesn't matter. And yeah, you generally find these on like logic boards or smaller, kind of maybe more so on non-power supply circuit boards, maybe. You do find them on power suppliers, but generally not a lot of them. These are generally surrounded by logic chips or little processors, mini processors, or FPGAs and things like that sort of stuff, which again I'll go through in a future video if you like these ones. So yeah, that's a ceramic disc capacitor. You also get a very similar looking one, which is this blue one here. This one you'll be able to read the writing on, so we'll zoom up close to that and have a look. It will have, again, voltage rating that says 400 volts, and obviously it will give you the capacity as well, but I can't really read that on the screen, so I can't really tell you what that says. These are more higher voltage usage capacitors. These are generally lower voltage. These can go from like 200 volts to 400 volts, and they're generally used on power suppliers to isolate grounds from high voltages, generally next to transformers. These are also called wire capacitors, and again I'll go through the function of what that kind of means in a later video. So yeah, these you'll find in high power suppliers next to the big ass transformers, and you might find quite a few of them, especially around the outside of the board where they've got the screws for a power supply, say in a TV. You'll have the metal tabs with the screws, and you generally find these are generally connected from a high voltage rail to ground, and this is the kind of one of the functions of what that does. So these are both disc type capacitors. This one, as I say, is called a wire class capacitor. There's also an X class, which I'll show you up next. And again, they do high voltage. These do lower voltages. I think they can go up to about 50 volts, whereas these generally go up to sort of anywhere from mains voltages to, you know, sort of 600 to 700 volts odd. So they're generally used in higher power applications. So let's have a look at the next one that we have in store, which is called an X-class capacitor. And last but surely not least, this is an X-class capacitor. Now you'll generally find these, where would you generally find these? Like the fans that you have to keep you cool, you know, the big sort of floor standing fans. You find these on the back of the motors in them if you take the hoods apart of them. That's one place you'll find them. Another place you'll find them will be on the back of where the mains power comes in. The wiring, you'll generally find one of these sitting on top. These are generally designed to go across the mains, so you have 240 volts going here and here, AC. So these are generally, they can be a lot smaller. These ones typically are Panasonic ones, I do believe. And this one, as you can see, let me zoom in just a wheel a bit. Not zoom in, you know what I mean, focus. 68 microfarad. And we've got a voltage rating, yeah, 275 volts. This one is capable of. So yeah, you'll generally find this on the end of a mains cable, obviously inside an appliance. Yeah, this is an X-class capacitor. These again do not have electrolyte in them, if that's at all correct, which is not, but who cares. these are generally made up of like a polymer. These are like a thin film, sort of like a plastic, not plastic, but like a plastic kind of wrapping of a material. And I think they do actually contain electrolyte. I'm not 100% sure on that, but I might actually, as you can see, I was going to say I'd crack one open, but you can see it's actually potted on the inside. And I think the reason why they're potted is obviously because they're across the mains. If they do blow, they'll probably blow quite badly. I was going to say hard, but I'm not going to. So yeah, these are X-class. That's your Y-class. That's your ceramic. That's your electrolytic. Those are the types of capacitor you have. So X-class, Y-class, ceramic, electrolytic. These contain a gas. A gas and electrolyte, a liquid. This does not, nor does this one, as far as I'm aware. These are kind of like metal film-ish, kind of polymery, kind of izzy-wizzy stuff in there. I don't know, I've never taken one apart, but not the same as these. These are generally mains voltage rated or higher. These are generally up to say 50 or 100 volts, so generally lower voltage applications, and these can vary from like 2.5 volts all the way up to mains rated 450, 500 volts, 600 volts even. So really, I mean, there's a quite a variance in, you know, what you can use these types of capacitors for. So I think I'll go into that next. So we'll go through what an electrolytic capacitor is used for, typically. What a ceramic capacitor is used for, typically. A Y-class capacitor used for, and an X-class capacitor used for. So we go for, I'll tell you what, let me go grab a piece of paper and we'll actually draw the circuit diagrams underneath. So when you look at a circuit diagram, or a schematic as they're more commonly known as, you can see the actual symbols and how they're written down on an electronic circuit, so you can identify them easily. So let's go and do that. Let me grab a bit of paper and I'll be back. So these are the capacitors here that we have. So let's have a look at their circuit symbols and how to recognize them in a schematic diagram or a circuit drawing. So this one here is electrolytic. It's generally seen as being written or drawn, however you look at it, like so. Okay, so the thicker pin here is named as the negative, and this side is the positive in a circuit. Okay, this one here, which is the ceramic disc, is just shown just like that, and my pen is running out. Typical. Again, there's no polarity, so you can have plus or minus, minus or plus either side. This one is a Y-class capacitor, indicated the same as that, so depending on where it is on the circuit, you'll know what the function is of it, so that differentiates the two between. And this one as well has also the same actual drawing on a schematic, but again, depends on where it's placed on the depends on where it's placed on a schematic, depends on its function. So for example, for these two, I'll give you an example. So you have mains supply coming in to say a power supply, have that rail, and you have that rail. Obviously it's not polarized at this time, so that's why they don't need to be polarized. And what you will find is the X capacitor, which is this one. This one's the Y capacitor, X class, Y class. Now X class will be found in a circuit like that. Okay, so that'll be an X capacitor, X class. Now a Y will typically be found in a circuit like that. That'd be a Y capacitor. So again, looking at a circuit, if you know circuit diagrams, you will kind of know where it's placed in the circuit as to what function that actual capacitor has. So when the main's coming in, say 240 volts, this is where you'll find an X-class capacitor and a Y-class capacitor, typically. Maybe not in that fashion, maybe the other way around, depending on how you want to actually run your circuit, but that's typically where you'll find these four. They're used for suppression, so filtering out any unwanted noise on the mains coming in and or going out. Same can be going both ways. So electromagnetic interference and radio frequency interference as well. So if you have a radio, for example, or something that is sensitive to say voltage spikes or noise, you'll generally find this in this arrangement in the power supply for that device, say a radio for example, and it will help cut out any unwanted frequencies. So they're also used for safety. I won't go into that right now, it's quite a big rabbit hole I'll go into, which I'm not going to go to now. These are again lower voltage, sort of for lower voltage applications, and as I say, these ceramic capacitors will fill, well, let's go with the electrolytic. So these are used as bypass capacitors, so typically called bypass capacitors. Okay, and they're generally bulk capacitors, and so in a circuit like this, after the voltage has been rectified and it's ready for use, then you'll find this on the other end. So say here, for example, using the same diagram, so that's a transformer, have the windings, and then you have a tap coming off, for example, like so. You could have that capacitor there. Not a very good drawing, and I'll go into detail if you guys are more interested. These can also be used as bypass capacitors, but these are actually for low frequency, filtering out low frequency noises on a circuit. So these filter out the low frequency, these filter out the high frequency. So again, these are used in more sort of logic circuits. If you've got signals that are, if you're waiting for a logic chip to wait on a signal, for example, and you don't want any sort of false triggering if the processor is about to do something, you can use these in line with the power rail on those chips or those devices, and that will filter out any sort of slight voltage spikes depending on the frequency, and the same goes for those as well. So that's the basics. I'm not going to go too much more into depth. I'll go into more schematics as we go along. What I'm going to do, I'm going to go through each components, like resistors, like chips, certain chips, the numbering, how to recognize them, how to use them, what they're used for, and I'll kind of do like a series of videos explaining all this kind of stuff. So this one was basically about capacitors, not in detail, but again, as we go along, I'll start doing some more detailed videos. So I hope you like this video anyway. Please subscribe, give me a thumbs up, comment, link and subscribe and all that stuff. See you guys next time, tube users.